30. Please check the announcement. Okay. So when we mentioned about 1 hour 3 and 1 question, right? It's actually covered under topics 1 and 2. Okay. Topics 2 is the ones that have more because there are different parts of it. Okay. So we will quickly go through topics 1, 2, and I'll show you some tutorial question. And please take note. Topics 1, remember we learn about what do we learn in topics 1? We learn about different variable, right? We have measure, control, set point, manipulate, and disturbance, right? Okay. So how to identify whether it's a measure variable? Normally, we refer to the instrument, right? Like in this case, if I measure this one, the temperature here, so the temperature of the fluid is actually the measure variable. You should be able to identify that. And then, what is control variable? Control is the one after I measure, it will transmit to a controller, right? TC stands for temperature controller. So the one that we measure is temperature. The ones that we control is also same as the temperature in the fluid in the tank of the fluid in the tank. So this is measure. This is control. Set point, of course, it will be given in the controller. What about manipulated variable? We have 5, right? We have 5 important things that we need to identify. We need to identify what is measure, what is control, what is manipulated, what is final control elements, and different signals, right? Manipulated variables, how to identify? Manipulated is the one that we need to refer to the final control elements, right? So in this case, this is my final control element. If I open and close this valve, I will control the flow rate of the hot oil in. So the manipulator is the flow rate of the hot oil. Okay, let me repeat it. I will give you some example later. These are the examples that we have in chapter 1, topics 1, 1.2. Disturbance is the ones that come into the system. So sometimes we call it inlet, sometimes we call it disturbance. Because anytime any changes to the inlet, we call it disturbance. So in this case, disturbance is the inlet temperature. Alright? This is one of the examples, or these are the 5 important things that you need to take note for topics 1. Right? Then after that, we talk about different symbol where we wanted to draw the P and ID or the process diagram. And remember, electrical signal always refer to dotted line. Pneumatic signal is the line with the double slash. Of course, you got the sonic and hydraulic signal represent differently. Process is just a line, okay? You need to know this if I ask you to draw some simple P and ID on the process diagram, right? And then the process control drawing, we have different letter, right? The first letter always have 2 letters. First letter has different meaning, second letter has different meaning. Let's say if I want to measure temperature and it need to transmit, right? So I can have 2T because the first letter represent temperature, second letter represent transmit. So TT is meaning temperature transmission, temperature transmitter. Okay, and I think I share with you all some examples. So if I want to have flow transmitter, what letter should I use for the controller? Flow transmitter, I should use FT, right? And if let's say speed is what? Let's say speed indicator can be S, indicator is I, so it can be SI, things like that. So all this, if I give you this table itself, you should be able to identify and write it down, okay? Tutorial 1 is the example we learned for this topics 1, right? First of all, it mentioned about the fee, enter, blah blah blah. Then for each of these control loop, you need to describe These are the 6 important things that you need to know. The first one is what? What is measured, variable, control, manipulate, final control element, types of transmitter, types of control transmission, types of measure transmission signal. So how many loop are there for this system itself?
3.
3, right? 3 loop, and each of it, is it open or closed loop? All closed loop, right? Yes. So you need to know what is open and closed loop. Please do some revisions from the lecture note. So we have the loop for 10, loop for 12, and loop for 14. I think there is another one which is the indicator only, which is PI. Okay. And for each of these loops, you have to identify. Let's say one of the example we have is loop 10. Loop 10, where is it? It's this one, right? So if I ask you what is the loop 10 measure, it's a variable. So how you should identify it? You should follow the flow, right? So what you have here, this is your instrument for loop 10. Then you send it to here, control here. So loop 10 FT stand for flow transmission. And flow transmission in this one is actually the inlet flow. So the measure variable is the feed flow rate. Okay? What about the control variable? What is our control variable?
The inlet feed.
Also flow, right? So it's also the feed flow rate, because what you have under the control, this is your controller, right? You have FC. FC stands for flow control. So you have this control variable, which is the feed flow rate. What about the manipulated flow rate? A manipulated variable. Manipulated is after the final control elements, right? You actually manipulate the feed flow rate. So in this case, the manipulated feed flow is also the same. Okay? And what about this one? The final control element in this case is our control valve, right? The next one we ask is about the signal. The measure signal is represented by this one, right? After you measure, you send it to controller. It's a dotted line, so it's an electrical signal. All right. What about the control signal? Control signal is represented by this line, right? That is pneumatic signal. Okay, it's actually quite straightforward. This types of question it is come out, and we have to describe the loop also, right? Let's say loop 10. How shall we describe? When you describe, there are certain keywords that you need to write, right? First of all, in this case, you know the flow in the pipe is measured with the flow transmitter, and then the flow transmitter have this label FT10. Electrical signal is sent to the flow controller. So from here to here, you must identify it's an electrical signal sent to this location. And when you have a circle with a line underneath it, that one means that the controller is mounted in control room. So the keywords control room you must mention. And the controller send what kind of signal to the final control element to manipulate what? These are the things that you need to able to describe. Okay? Okay, Ken? Any question? If you don't, please ask. So similarly, if I repeat for this one, right? Loop 12. What is the measure variable for loop 12? Anyone? What is the variable for loop 12? A measure variable. Level, right? Level in the tank. So you have level in the evaporator. The control is also the level. The manipulator, what is the manipulator for loop 12? The flow rate of output, right? Or your product, because if you open and close this valve, your flow rate will be affected. So you manipulate the output flow rate, okay? And then your final control element is also a control valve. The measure signal is pneumatic. The the control signal is electric for loop 12. Okay. What about loop 14? What is loop 14? This is my loop 14, right? So loop 14, what is the measure variable? Analysis stands for what? Composition, right? Or the quality, the product quality. Means that the product here, I need to measure the composition. A is analysis. So the measured variable for this is product quality or product composition. What about the control variable? Also the same, the quality or the compositions of the product. Manipulated, what is the manipulated variable? Manipulated variable is what?
The steam.
The what?
Steam.
The steam flow rate, right? Because if I open and close this one, it will affect the steam flow. So the manipulated for loop 14 is the steam flow. And what about the final control elements? The control valve, right? And then the signal is, this one is dotted, which is electrical, and the control signal is pneumatic. Okay? This is how we do for this type of question. So you must able to identify all the three importance variable, final control elements, and also the signal itself, and able to describe. Right? Let me move on. Topics 2. I think that one is more or less a topic 1. So topic 1, if you if you pay attention to it, you should be able to at least able to answer one question. All right. Topics 2, I think is more challenge 1. The ones that's okay. Topics 2, first part we learn about the process dynamic, where we start with the Laplace transform. Laplace transform, you must be able to use this table. This side is the function of it. If I have a function, I transform, the small letter will become capital letter. Any difference function symbol, like for example H, Q, or whatever other alphabet, when you transform, right, you should transform from a small letter to big one. This one is impulse. When you transform impulse, become 1. When you transform unit step, which is 1, become 1 over s. Ramp become 1 over s power 2, etc., etc., etc. So you have transform, you also need to inverse. So when you inverse, you have to use this side of the table to inverse it back, okay? And we have this tutorial 2, this example. Still remember? Right? Solve this by using Laplace transform. Let's say, what is this? This one is dy dt plus 3y equal to 0 when y 0 equal to 2, right? How to do this? When you need to use Laplace transform, you have to do it one by one, right? So always have the table beside you, alright? So the first part is dy dt. dy dt is this one that we need to use, right? But now my function is y. So when I transform dy dt, become what? Oh, okay, very expert already. So I can test more complicated question now. Maybe not in term test, maybe in the final exam. I keep you all one now. Okay, and after that 3y, when we transform, that become 3 capital Y, right? Sometimes you all will ask me whether you need to put the bracket S or not. The bracket S is actually to show that the domain of the Laplace phase. If you understand the capital Y is the Laplace format, right? It's okay for you to don't show the bracket S, because you see some of your transfer function, right? In the Laplace format, you only have H prime divided by Q prime. And actually the H prime and Q prime, right, should have a bracket S. Sometimes you show, sometimes it doesn't, so it doesn't matter. As long as you know that when you are in the capital letter, you actually in the Laplace format. And transform of 0 become still 0, right? So you have to combine these three to give you this answer. Transform of this give you the first part. Transform of this give you this one. Transform of 0 give you 0. Okay? Can? And after that, what should you do? After you have the purpose of changing this into this, right? Is you want to take away the dy dx because you don't want to solve dy dx by integration. So you want to solve something just y and s. Alright? So in this phase itself, it's just a linear equation. You need to solve it by putting capital Y at one side and all the s at the other side. So what you need to do is, first you have to sub your function at 0, which is given by the question say the initial condition where y equal to t0, the y value is 2. So you have to sub this one as 2. That gives you this equation, right? All clear? Then after that, we just try to combine the capital Y and arrange it, factor out your capital Y. That what left here is s plus 3 minus 2. So you bring minus 2 to the other side and arrange. So you have 2 divided by s plus 3, right? Okay, but when you are at this stage, means you need to do inverse already because you already so-called solve your function in the Laplace phase, but you cannot use the Laplace phase to calculate your function. You have to bring it back to the time domain, so you have to inverse it. So when you want to inverse this one, you need to refer to the table again, right? So you need to inverse it by using this table. So you must look at when you inverse, it's always at this side of the table. So which part of the table you need to find similar to this one? Is it this one or this one or this one? First, second, third. First one, right? And if you look at first one, right, it's always s plus b, right? So over here, you have to identify what is the b. So what you have is b equal to 3, right? 2 is actually something you multiply by 1, so you can always bring it out. So when you inverse this one, it becomes e power of minus bt, right? And you know b is 3. So from here, when you inverse, the y is actually capital letter, then become a small letter again, alright? Inverse means whatever capital in the Laplace, you bring it back, will become a small letter. And then inverse of this part become exponential of minus bt. And minus bt, you know that b is equal to 3. So this is your final answer. You should remember you have a 2 here, so 2 is always there. And then inverse of 1 over s plus b is this one. Alright? By doing that, you complete your complete solving the differentiation equation by using Laplace method. Okay? Any questions so far? No, right? And this is a simple one. The more complicated one will come like the function will not be so straightforward. The dy dx can be also dy dx but multiplied by something plus something, maybe equal to exponential or maybe equal to ln or something like that. So you all should be able, okay? Alright, so this type of question could contribute another maybe 10 or 5 marks on it, alright? So take note. Yes. One slide before. This one? Okay. Can I want all of you to understand it. Okay.
This is like the coming for the response.
Alright, shall I? Can I? So after the Laplace, we also learn about the using the mass balance and energy balance to develop the process dynamic, or the what we call it, the transfer function, right? So example we give is this one, the first order system. We have Q in, Q out equal to this one. So the volume is given by A multiplied by H. So you got the tank level here. A is the cross section, tank level is H. Let's say I want to develop the transfer function, first order transfer function.